So in this question we are given a Wheatstone bridge, and initially the Wheatstone bridge is balanced, it's in a balanced condition, and now the resistance R3 is heated. It is heated by 100 degrees Celsius. So because the resistance R3 will change because of the temperature change, the Wheatstone bridge is no longer balanced, and there will be a potential difference between S and T. Normally, when the Wheatstone bridge is in the balanced condition, the potential difference between S and T will be 0. But when the balance is disturbed by changing R3, by heating the resistance R3 and changing its resistance, the potential difference between S and T is no longer 0, and we have to find what that potential difference becomes. So you can pause the video over here and try to solve the question on your own, and I will move into the solution now. तो हमें गिवन है कि R3 को हमने हीट कर दिया, and the amount by which the resistance changes, we can calculate it. So we can calculate the new resistance R3 prime. That will be equal to R3 times 1 plus alpha delta T, where alpha R is the coefficient of temperature dependence of the resistance, and the values are given. So we know that the new resistance R3 is 312 ohms. So we have drawn the new circuit, and in this circuit you may notice that I have removed the voltmeter, and the reason for that is that there will be no current through the voltmeter branch. So this voltmeter is shown in the question to denote that we are trying to measure the potential difference between S and T, but we are not given whether the voltmeter is ideal or non-ideal. In the case when we are not given any information, it is safe to assume that the voltmeter is ideal, in which case it has infinite resistance. तो voltmeter का resistance infinite है, इसका मतलब इस branch से कोई current नहीं flow करेगा. Even if there is a potential difference between S and T, no current flows through this branch, and we can remove in any circuit, we can always remove any branch through which there is no current and analyze the circuit without it, and the analysis will be correct. So ये अब सिंपल सा सर्किट हो गया, एक बिल्कुल पैरेलल वाला सर्किट है कि एक बैटरी लगी हुई, एक आइडियल बैटरी है, और उसके साथ दो रेजिस्टेंस की ब्रांचेस है जो कि पैरेलल में है. सो बोथ दीज रेजिस्टेंस ब्रांचेस are in parallel with the battery, and R1 and R3 are in series, R2 and R4 are in series. So इन दो ब्रांचेस में जो करंट फ्लो करेगा वो हम निकाल सकते हैं very simply. So I1 is the potential difference of the battery, the EMF of the battery, 50 divided by the sum of the resistances. So this is the current flowing through this branch, and this is the current flowing through the second branch. तो I1 और I2 आ गए, और फिर उसके बाद we can simply write the potential at the point S, Vp minus I1 R1, right, and the potential of the point Vt as Vp minus I2 R2. So I have written Vs and Vt both in terms of Vp, right. Vp you can say is a kind of reference point here for Vs and Vt, but once we subtract, once we find the potential difference, Vp disappears, and we are left with I2 R2 minus I1 R1. So I could have done it straight in one go also. Vs minus Vt I could have gone. So for Vs minus Vt I have to go from T to S and add all the intervening potential differences that I encounter. So if I go from T to S in one go, I'll encounter this R2 resistance first, but I'm traveling against the current, so I get a potential difference of I plus I2 R2, and then I'm crossing this R1 resistance in the direction of current, तो मुझे potential difference मिलता है I1 R1. तो it's quite simple, this calculation, and finally we get this answer. So this question was looked a little intimidating at first, because ये वाली जो potential वोल्टमीटर वाली जो ब्रांच है, इसको देख के ऐसा लगता है कि सर्किट बहुत कॉम्प्लिकेटेड है, सर्किट को सॉल्व करने के लिए KVL KCL लगाना पड़ेगा, बट It's just a very simple question, and I hope all of you were able to solve it. अगर आप ये क्वेश्चन सॉल्व कर पा रहे हैं तो it means that your preparation is going in the right direction with regards to DC circuits. अगर आप नहीं भी कर पाए तो I hope you revise the concepts and try to solve it, because DC circuit is one of the easier chapters of JEE Advanced, where most of the questions, 90% of the questions that come in JEE Advanced are very solvable. So thanks for watching and bye.